रिपोर्ट दिख रही नहीं, एग्जीक्यूशंस में आता है क्या ये रिपोर्ट?
Good evening, everyone. We are going to start in 4 to 5 minutes. Okay, so let others also join.
Hi guys. So we'll just start in a minute. Just wait a minute. Let others also join. We'll start in a minute. Fine?
Okay, ma'am.
Yeah.
Yeah.
Okay, ma'am.
Okay, guys. So today also we'll have the presentation. So who all
Let I start.
haven't? Okay. Okay. Yeah. tell me your name, please.
Sangeet, ma'am.
Sangeet. Okay.
I'm Diksha.
Okay, fine. So after Sangeet, who wants to
Me, ma'am.
Diksha.
present?
Ma'am Sajruddin.
Dikshant. Okay.
Ma'am, Himanshu.
Okay. Just a minute. Just a minute. After Dikshant, Sajruddin.
Yes, ma'am.
Yes.
Okay,
After
fine.
him,
Okay, Himanshu.
yes, ma'am.
Okay, fine. So after Himanshu,
Ma'am, I can present some.
okay, Soumya. Okay, fine. So we'll just start off with Sangeet. Sangeet, you can just share your screen and accordingly present.
Yeah, yeah, okay, ma'am. It is visible.
Yeah, it is.
Good evening to everyone. Today about my project is clustering university students spend by spending. Project title clustering university students by spending patterns using K-means and box plot analyze. Project descriptions. University students often have a different spending habits depending on lifestyles, allowance, and financial background. By applying customer segmentations with K-means clustering, we can group students into categories: budget, balanced spenders, high spenders. Based on the survey's response, this helps understand financially behaviors and design better students' financial programs. Problem. I have taken a problem statement. University students often showing very different spending behaviors depending on the lifestyles, background, and preference. For example, some students spend mostly on academy and foods. Others spends more on entertainment and shopping. By applying K-means algorithm, we can group students into distant categories. Clustering, everyone knows clustering means grouping similar things based on their spending. This is very useful for financial planning, targeted service, and behavioral understanding. Objectives: to analyze university students' spending habits using several data, to apply K-means algorithm clustering for customer segmentation, to visualize spending categories across clustering using box plots, to interpret clusters and provide insights. Data sets, 4 steps, data sets. Since real survey data is not always available, we create a synthetic data sets of 200 students with 5 spending categories. Example: food spending, monthly, transport spending, entertainment spending, academic spending, shopping spending. Values are generated using a normal distribution to mimic realistic spending. Fifth step, methodology. What are the methodology I have used? Step 1, data preparation. Generating synthetic datasets ensures no negative values. Store data in a data frame. Step 2, data standardization. Spending values have a different ranges. Standardizations mean 0, standardization 1 ensures fair clustering. Step 3, K-means clustering. Use elbow method to detect optimal number of clustering. In our case, K3 is a chosen. Assign each student a cluster label. Step 4, use box plottings to show description of spending across clustering. Step 5, clustering profile. Calculate mean values for clustering. Label clustering as cluster 0 equal to budget conscious, cluster 1 balance spenders, cluster 2 high spenders. Result: elbow method. The elbow curve showed at the clusters in 3 approximating choice. Box plot insights: food spending on cluster spend continuous lowesting, another moderating, and one night. Entertainment spending. Clear difference occur. This we can see in the coding as well. The seventh step is a real world application. University management identifying students who need financial guidance. Financial servers offer budgets management tools to specific segments. Retails and cafeterias target promotions to high spenders. Policy makers understand students' financial stress points. we see the program. Student spending cluster Python programming using I have imported pandas, numpy, MATLAB, cbond, sklearn cluster, sklearn pre-processing cluster, standard scalar. Step 1, generating synthetic data. We are generating a synthetic data of students, food spending, transport spending, entertainment spending, academic spending, shopping spending, and the data frame. Clean negative values. We are cleaning the negative values and standardize the data. Step 3, applying K means elbow method to find the best K. Chosen K equal to 3. And fourth step is a box plotting analyze. And step 5 is a cluster insights. And finally, if we run this program, we will get the output of this. Elbow method for optimization K. Elbow method for optimization K. Integrate a number of clusters. See here the graph for elbow method for optimization K. And here the food spending by the clusters. Here the spending amount and here the entertainment and here the entertainment spending by clusters. Here the entertainment spending amount. Cluster 0, cluster 1, cluster 2. And final output of the program. Cluster 0, cluster 1, cluster 2, clusters and academic spending, shopping, food spending, transport spending, entertainment spending. Cluster summary. And conclusion for this program, conclusion for this project. K means clustering successfully grouped into 3 distance categories. Spending habits differ strongly in food, entertainment, and shopping categories. Box plots, clear vision, evidence of spending behaviors difference. This approach can be extended with the real survey data for better insights. Ma'am, I'm done, ma'am.
Okay, fine. Okay. Can you just scroll up where you have given with the after where you have gone ahead with the k-means clustering, that part? Can you just show once?
Yeah. Output, ma'am.
In the yes, what details of
Yeah.
what clusters you have received? Yeah.
Yeah. I'll show you. Yeah, here, ma'am.
That is the elbow method. There you have calculated the number of like the how many clusters, right? Then after
Yes, ma'am.
that, in the k-means part.
Here the cluster food spending by cluster, ma'am.
Okay, fine. Okay.
Here is
And next one.
entertainment spending by cluster.
Okay, fine. Okay,
Yeah, yes.
fine. It was okay, fine.
Yeah,
You
okay.
can just stop sharing.
Yeah, okay, ma'am.
Yeah, next is Dikshant, right? You can just present your screen and start with the presentation.
Is it visible now?
Yes, it is.
Hello everyone. Today I will present my
Yeah,
project
audible.
on. Hello everyone. Today I will present my project on customer segmentation using mall customer data. The main goal was of this project was to group customers based on their age and spending score. This can help businesses understanding their customer base and to design targeted marketing strategies. I have used small customers data easily available on Kaggle This dataset contains around 200 entries, and main columns are customer ID, gender, age, annual income, and spending score. For this project, we are only focusing on two columns, age and spending score. Our first step will be importing and loading the data. Now we are checking the shape of the data. For custom ID, here's the columns of the data set. We are checking if there's some missing values or missing data in the set. This data set is clean, so we do not need any cleaning or any sorting this data set. Now here we are describing our data set. Here we are only going to select those columns, age and spending score for our clustering distribution of each. Here we have made an histogram. We plotted this histogram to see the distribution, like ages mostly between 20 to 40, and spending score we have uh, made to see how customers are spread in terms of spending habits, like generally between 1 to 100. Next of us, we are also visualizing more scatter plots for this graph. To understand the relation between age and spending score, we created this scatter plot. Here we could already notice that customer tends to form groups naturally. They don't spread randomly. Like some younger customers have very high spending, old age customers have low spendings. Here we have made different histograms scatter plot to diagnose more. Like this diagonal histogram shows age is spread mostly around 20 to 40. Annual income is centered around 40 to 80K. Spending score is around 0 to 100. The scatter plot shows that how features are related to each other: age versus spending score, annual income versus spending score, which shows that but there are some groups forming, like good for clustering, age versus income. Now we have to choose the number of clusters. We use elbow method, which is generally used to decide the number of clusters we are for our project. For each possible values of k, we calculate cluster sum of squares. As k increases, WCC within cluster sum of square decreases. In this plot, there is a sharp decrease in the curve up to k equal to 3 or k equal to 4, not exact. So after that, it concludes that after that curve flattens, additional clusters won't significantly improve our clustering. Therefore, optimal number of clusters is around 3 and 4. Now we are applying k means with optimal. Here we are visualizing the scatter. Using k means, we divided the customers in 5 parts. This chart here shows each cluster in a different color with a black cross or X mark showing different centroids. There are 5 groups, like high spending young group, low spending older group. Low spending older group focuses, company can focus less on that older group. Now next step is cluster profiling. Here we have already done. We divide the customers in 5 clusters, and it shows it helps in making business strategies. Now we are checking sell outage score, which is another way to find the right value of number of clusters. Okay, sell outage score generally measures how well points fit into their clusters. Here we found that our sell outage score was 0.44522. If it is close to 1, then customers are well separated, and if it is around 0, plus clusters overlap. Here is my conclusion. We perform customer segmentation using mall customer dataset. Using elbow method, we selected a number of clusters equal to 5 and applied k-means clustering and visualized some clear graphs. That's all.
Okay, Dikshant. It was a great attempt from your end. So over the weeks, you have prepared well about your presentation skills has improved. That's nice to see.
Thank you, ma'am.
Yeah. Okay. Uh, so after Dikshant, it is Sajiruddin, right? So Sajiruddin, you can just present your screen and start with your presentation. Sajiruddin, you're there in the meeting?
Yes, ma'am.
Yeah. So you can just present your screen and start with your presentation.
Okay, ma'am. Is my screen visible?
Yeah, it is visible.
Good evening. My name is Sajruddin Alam. I have worked on the project of email spam detection system, which is based on supervised learning, which we have been learning from the last week. My main objective of the project was to identify the emails into two categories: spam or not spam. For that, I have used tree-based classifiers along with KNN SVC. Starting with the coding section, I have imported the necessary libraries. That includes pandas, NumPy, and visualization tools. After that, for NLP, natural language processing, I have imported the NLT, natural language toolkit for natural language processing. After that, I have mounted the dataset using the Google Colab Drive mount. I have created a copy of the dataset so that in future, if there is any necessary, I can create another copy. I have checked the shape, column names, and data types so that it will be easy for me to interact with them. Info helps in me getting the data type of the along with getting the total number of rows present in the data. Describe used to help the numerical data types columns, which they here unnamed zero, which is the ID and label number. After that, I have checked the null values. During the data cleaning process, I have first dropped the unnamed column, which and label column, as there were two columns present. Label num, which represents the label in terms of the encoding form, and label zero is used as the ID, which is not necessary for the ML modeling. After that, for cleaning, I have renamed the columns for the proper so that it's shows proper what it represents. Text represents the email, and target represents its spam or not spam classes. After that, duplicates check. Duplicates have been removed, keeping only the first copy of the duplicates. Performing EDA. EDA is performed to check how there are relation between the spam and not spam email text. Here I have checked the percentage. Spam data is 70% of the total data, and not spam data is 70% of the total data, and spam is 29.2%, which I have shown in the form of pie chart. For the text analysis, I have counted the number of characters, number of words, and number of sentences using the NLT toolkit, so that it helps me in analyzing the text. Describe method helps in describing the text data of the whole. For that, I have described the text numerical columns for ham data and the spam data. From the ham data, we can see that the mean number of sentences are 11. And from the spam, we can see that it is 17, while minimum value is 1, and here also minimum value is 1. We can see that there is not much difference from the description of both the datas. So it is not easy to classify them with the help of only the statistical values. So that for further analysis, I have checked the length of the length distribution. From here, we can see the number of characters, distribution of number of characters. KDE curve helps in getting the probability of the data falling in which category. With peak value being around 0 to 2K from here. From here, we can see that the most text data are having the number of 10K distributions. After that, there are very few emails having a higher number of word count than 10K, which can be treated as outliers. Word count distribution also helps in analyzing the number of words in spam and not spam data. Here, red target shows the spam data and blue target shows the not spam data, which also shows that after 2000, there is a long peak for the both red and blue, which shows there are very little messages containing more than 2000 words. Pair plot helps in analyzing the features distribution between the target between the different features. From the most of the plots, we can see that spam and not spam are overlapping each other, so it is difficult to classify them. But from the num words and num character graph, we can see that there is a little bit distribution between them. So we can use that to create a hyperplane to classify them. Correlation heat map also helps in analyzing the relation between the target and the num characters, number of words and number of sentences. You checking the target column, we can see that there is very little correlation. That is very small positive value. So there is not much correlation between number of characters, number of words, and number of sentences with the target. So it is also difficult to further analyze with the help of correlation map. For the data pre-processing, I have used the Potter Stammer, which helps in creating the tokens of the main words. Like running is returned as run, jumping returns as jump. Stem words creating for transformation. First, I have transformed all the text into lowercase. After that, I have created the tokens. Then after that, I have used the stop words to remove all the stop words included, such as the, is, and also checks this that it only contains alphanumeric characters. So that is numbers and alphabets, not any emoji or punctuation marks. So after that, I have returned the whole words using the join method. I have transformed the data. After that, I have checked the data. I have got new column transform text, which results in transformed data. Next, I have represented the words of spam messages and ham messages using the word cloud, which helps in analyzing the words which are most frequently used in both the messages. By using this, by analyzing the spam, we can see that the company, time, busy, subject, these words are mostly used in the spam messages, while in the ham messages, subject can also be found enroll, caught, ECT, extra hours found. After that, I have classified the different models for the training. I have listed all the models, starting with the logistic regression, SVC, super vector classifier, naive bias, decision tree, K neighbors classifier, random forest, bagging classifier, extra trees classifier, and the XGB classifier. Before that, I have already split the data into training and test data, with 20% test data and 80% being training data. I have created the abbreviations for the objects of the classifiers. And after that, I have created a dictionary so that I can train the models using a for loop without being so that I have not to run each model one by one. I've created a matrix list of accuracy, precision, and recall for the further analysis after the training. I have trained the models in a for loop So each models runs one by one. After that, I have model performance comparison of all the models with SPC sport vector classifier with the highest accuracy, precision, and recall, being the best model among the all the models. From the experiment, we can see that the sport vector classifier is the most effective task or most effective model for this task, achieving 98.1% accuracy. Overall, the project successfully demonstrates how learning can be applied to real world problems like email filtering. That concludes my project. Thank you.
Okay, Tajuruddin. It was a great, great attempt that has been seen from your end.
Thank you, ma'am.
Yeah. So next is Himanshu. So you can just present your screen, Himanshu.
Yes, ma'am.
Yeah, present your screen.
Okay, ma'am. My screen is visual, ma'am.
Yeah, it is visible.
Okay, ma'am. I start. Good evening, everyone. Today I will present my project on e-commerce clustering segment. The main goal of this project is to understand customer behavior and group them into meaningful segment. Why segmenting customer business can tailor marketing and strategy, increase sales and improve customer retention. Essentially, it about turning raw transaction data into actionable insights. For this project, I should the huge online retail data set. It contains transaction level data including invoice number, product description, quantity, unit price, customer ID, invoice data, and country. This data set represents customers from multiple countries, giving us a diverse view of buying patterns. The idea is to use the transactional data to identify patterns that reveal customer value and behaviors. The project is organized in a modular way. The data folder contains the raw CVC data. The RCC folder, SRC folder contains Python script or processing clustering, evaluating, and visualization the data. The output folder stores results like clustering profile and plots. Finally, the config folder has setting like the number of clustering and the clustering methods. This structure help in keeping the code cleaning, visual, and easy to understand. The first step, that processing, which is critical to reliable results. We remove rows with missing customer IDs because we cannot segment anonymous customers. We also remove transaction with negative or zero quantity or price as these likely errors or returns. Finally, we add a total column, multiply quantity and unit price. This prepares the data for feature engineering and clustering. Just a minute. Where, here. Next, we create RF feature recency, frequency, and monetary value. Frequency measures how recently customer purchased. Frequency measure how often they purchase. Monetary measures how much they spend RFM widely. RFM is widely used to marketing analytics because it captures the aspect of customer behavior. These features from the input for clustering allowing us to segment cluster based on their loyalty and value. something is missing. K-means divide. I implemented two clustering techniques, K-means and hierarchical cluster. K-means divide customer into a fixed number of clustering by minimizing intra-cluster distance. Hierarchy cluster builds a tree or clusters, which is visualized as a dendrogram to show relation between customers. These methods help uncover natural grouping in data that might not obvious otherwise. The choice of method and the number of clustering are configurable along flexible based on the business needs. Once cluster performed, it is important to understand their characteristics. Cluster performing calculates the average recurrency, frequency, and monetary value for each cluster. This helps answer questions like who are my high value customer, how rarely wise clustering profile provide actionable insight for marketing strategies such as identifying VIP customers or low value customers that need engagement. To make these insights understand, we visualize the result scattering plot so frequency versus monetary value for each clustering marketed. Easy to see clustering group dendrogram from hierarchy cluster provide hierarchy view similarity between customer visualization make it easier communication finding stakeholder and guide data provide decisions. Based on clustering and profiling high value frequency customer can target with loyalty programs and exclusive offers. Low value of infrequent customers may requires engagement strategy demonstrate how clustering turns raw data into actionable business decisions that can improve revenue and customer loyalty. This project taught me several key skills: how to process transaction data for analysis, how to engineering meaningful RFM feature, how to implement clustering algorithm in Python, how visualization result and extract actionable insight. In the future project real-time segmentation, predicting churn or automatic clustering profile to continuously monitoring customer behavior. The project was implemented using the Python library with like for Panda manipulating skit learn for clustering Matplotlib and C1 for visualization and PyLM for configuration. Using for modular script based approach ensure that the code is clean, visual, easy to maintain. Jupyter Notebook was used for exploiting analyzing to understand the data before building the pipeline. In conclusion, customer segment is powerful technique for understanding and engaging with customer. This project demonstrates how to transform raw e-commerce transaction data into actionable insight. Features engineering, clustering, and visualization. It equips business with the knowledge to make data-driven decision and improve customer relations. Thank you. Thank you, ma'am. I done. Hello. Hello. I am audible, ma'am.
Yeah, yeah, you're audible. I was facing issue in switching on my mic. Yeah, tell.
Okay, ma'am. I am done. So I can
Yeah,
start
yeah, I
sharing.
have seen. Yeah, definitely. Yeah.
Okay. Thank you, ma'am.
Okay, Himanshu. So next is Soumya. So Soumya, you can present your screen.
Kuch-
Himanshu, unmute yourself. Let's say mute yourself. Sorry. Yeah, Soumya, your screen
Is
is
it visible?
visible. Yeah.
Hello everyone, I'm Soumya Singh and today I'll present my project on bank customer churn prediction and customer segmentation. The project combines regression, classification, unsupervised clustering to predict the churn and discover meaningful customer segments. Um, the objective is to perform a regression, implement classification models like logistic regression, KNN decision tree, compare those models and apply clustering using K-means, hierarchical clustering, and TB scan. So the problem statement is the churn is actually the loss of the customer or the subscriber over a specific period of time. It signifies the problems bank faces, leading to direct revenue loss. Predicting churn before it occurs allows banks to design efficient strategies going ahead. So starting with the program, first I imported the Python libraries. Here I have used pandas and NumPy for data handling. For visualization, I use Matplotlib, Seaborn, missing go for plotting the missing values, and Plotly for expressive visualizations. For pre-processing, I've used sklearn model selections and train split, train test split, cross validation score, and standard scale for scaling purpose. For model evaluation, I've imported accuracy score, precision score, recall score, confusion matrix, classification report, and mean squared error, R square, R2 score, and more. Uh, for the models, I've used the linear regression model, logistic regression, K nearest neighbor, decision tree, K mean, TB scan, and clustering. Uh, for the data set, I have taken a customer bank customer details from a Kaggle data set, which is for churn modeling itself. I have mounted that dataset through Google Colab and also provided an alternative option by providing the link for the CVS file I uploaded on the GitHub repository. So firstly, I loaded the data using pandas, read CVS, and printed the number of columns and the total columns present here. The We can see that there are columns and for features such as row number, customer ID, surname, credit score, geography, as where they live, gender, age, tenure, balance, number of product, if they have a credit card or not, if they are an active member or not, and their estimate salary. Here, the exited column is our label. uh, if exited equal month equals 1, it means that they are churned, and if it's not, that means they stayed with the bank. So there are total 14 features here. Taking the first look into the data, we can see the first using the head, I have printed the first 5 columns, and using the tail function, I have printed the last 5 columns, showing the values. Here we can also see that many number of customers have a zero balance. So data information, for dataset information, I've used the .info function. This gives the quick summary of the data side, data types, and non-null counts of the columns. And then I checked for the total number of rows and columns to find the dimensions of the data set. Here they are around 10,000 rows and 14 columns. I've checked for the duplicate values and missing values, which are 0, which means the quality of the data set is high. Then I have used missing no for a matrix to visualize the missing values. This confirms that the data set has no major missingness. For understanding the variables, I've printed the all the column names and the date on the data type as well. I've used the describe function to find the mean, standard deviation, minimum and maximum values and the quartile ranges of each column. Then, then I checked for the unique values in the columns. Here we can see that customer ID and number have all the unique values as they are the identifiers. And geography and gender can be treated as a categorical data as they have only two and only two values or three values. Has credit card and is an active member can also be treated as an categorical column. Here I've removed the duplicate values and then I visualize the missing value columns using the bar chart. So we can see it is clean. Then I encoded the categorical data. Here I converted the categorical features such as geography and gender into numerical dummies with one hot encoding. And here I've used drop first true uh, to avoid multicollinearity for linear models. After the after dropping the duplicates, sorry, after encoding, we can see that there are more columns added here, such as geography as Germany, geography, Spain, and gender male. Here I have dropped the identifier columns since it is not needed for prediction and it might cause problems for the models to generalize. Here I have tried to detect the outlier. We can see that the balance is heavily skewed. Many customers have zero balance and a few have a very large balance. That distribution can harm distance-based algorithm and linear regression. So I created a new column here called balance log, where I converted the balance values to their logarithmic equivalence. So after plotting the balance log, we can see that the long tail which we could see here has disappeared and it the box become more tighter, which improves stability for models and distance models. Here I have uh, taken target uh, features separately. Here X is the predictor and Y is the target value. For predicting, we don't need the exited column, so I have dropped it here. And for predicting, we need that column, so I've saved that column in Y. Going further ahead, I have performed the scaling of the feature using a standard scaler because many algorithms are sensitive to feature scale. Here I've also performed exploratory data analysis to understand the variables and their dependencies. Here I've plotted a count plot for for exited count to show the imbalance in the data set. We can see that there are more customers who stayed for that means exited equal to 0. It means the customer stayed with the bank, and exited equal to 1 means the customer left the bank. Because of this imbalance, accuracy is not a sufficient metric, so we can focus on the precision and recall score of the models. These histograms shows the are for age, balance, and estimate salary. We can see that the age is concentrated around young to middle-aged customer. The balance is clustered at 0 with long upper tail, and the estimate salary
Chetan,
Three.
can you please mute yourself?
Sorry, ma'am.
Yes, Soumya, continue.
um, yeah. Here we can see that the estimate salary is widely spread. These patterns suggest that feature engineering and scaling is very essential here. I've also plotted a correlation heat map here. This shows a pairwise linear relationship. We can see that there are no extremely strong linear correlation with exited, which indicates that churn is likely driven by complex, possibly non-linear interactions rather than a single linear effectiveness. Next, I've also plotted a histogram for gender and geography to see if it influences the prediction as well. So here, gender difference are minimal. Gender alone won't be very predictive. But for the geographical one, we can see that France here has the least number of churn. Um, and Spain here, yeah, Spain here has the least number of people who left the bank. So moving ahead, I've also plotted a box plot comparing age distribution across zone. We can see here that older customers show slightly different distribution. So age could be a factor for targeting the retention offers. Moving on to models, uh, I've performed regression. Uh, Firstly, I used a simple linear regression here to predict balance from estimate salary alone. Uh, here I have here I have printed the results of R, R square, mean squared error, and absolute error. We can see that the R square score is very low for this, and the mean absolute error is very high. And the scatter plot of the predicted versus actual values shows uh, is very disposed, and we can inference that uh, a single value of salary alone cannot be is not sufficient enough to predict correctly here. Then I used multilinear regression here. The features I've taken such as age, tenure, number of products, if the customer is an active member or not, and encoded geographical and gender features as well. We can see here that the R2 score improves dramatically here, and mean absolute error is also low as compared to the simple regression. Here, through the plot, you can see that the predictors was actual scatter plot is a tight cloud close to diagonal. This indicates that balance is shaped by many interacting factors. Multi-factor linear model captures most of the variabilities here. Then I have used polynomial regression. Um, we can see that polynomial regression has the best R square score and has least mean absolute error as well. We can see that it is fitted quite well here as well. However, it can also indicate that the model is overfitted because it is a very flexible polynomial model. Um, Therefore, before if it scores well, but if we want to implement this model or use this model in actual scenario, we have to first. We should first perform cross validation or hold outside to improve its to check its generalization. Then I have used Lasso's regression as it reduces overfitting and can select important features. So here we can see it has an R2 score of 0.87 and mean absolute error of 14K. Uh, this we can also see that its result is almost similar to that of multilinear regression. Moving on, I have also compared these model side by side, their score side by side. Here we can see from the comparison score that linear regression performed very poorly. Polynomial regression has the best fit show, but could be overfitted. And multilinear regression and lasso regression shows almost similar score. Here we can see that it is 0.87 and here it is also 0.87 and MAE is around 14K and here it is also exactly the same, almost the same. Uh, from this result, we can say that the salary alone is not very predictive. Multiple features give a strong interpretable model. Polynomial model may dramatically increase performance, but it risks overfitting. For if we want to deploy a model, multilinear regression and lasso regression can be the best choice here. Now I've performed classification. Firstly, I have to split the data set into train and test and have to stratify equal to 5. This preserves shown proportion in both sets, which is crucial for imbalanced targets. And we scaled the here we are scaling the uh, prediction with standard scale. Uh, this scaling is essential uh, so that the model fits perfectly. So I have created the model here of a logistic regression with maximum iteration to 6,000. And then I have trained the model here using the fit function. and then predicted its value. Here we can see it has achieved reasonable accuracy of around 0.807. Uh, but we can see that the recall score here is not very high, meaning it is missing some actual churn. Um, this indicates missing churns means it is predicting false negative, that the false negative are very high. It can be costly if we see it from a business perspective because if they leave, the customers of the bank are leaving without any notice or retention offer. Uh, Nextly, I have trained a KNN model here, created the KNN model, fitted it, and predicted the value. Here we can see that uh, it has a accuracy of around 0.82 and precision of 0.60. The precision is very low, uh, and the recall is 0.34 around. It is likely due to overlapping classes in balance label or the spread region, or this can also be caused due to the zero balance customer, as the KNN is sensitive to the choice of K as well. Next, I have created a decision tree model. I have created a decision tree model with the maximum depth of 5. Um, the decision tree captures the non-linear relationship and handles the mixed feature types without requiring heavy scaling. It achieves the best score here of accuracy around 0.85, precision of 0.78, and recall of 0.40. Um, the three are interpretable and they often yield high recall if the depth and the pruning are tuned. To control the depth here, I will the max depth equal to 5. I compared all the classification models here. We can see for logistic regression, the confusion matrix shown here shows here the dark blue column is the true negative, and this is the true positive. Sorry, false positive here, and the false negative is here, and the true positive. So, will be focusing on the false negative column, which is this one for each of the matrix, as these are the churners that the model failed to catch. Um, uh, we want to reduce this false negative score even if it increases the false positive. Comparing all of them, we can see that the logistic regression has around 332. Uh, 332 false negative. The KNN has 276. Oh, sorry, 267 false negative, and the decision tree has 244 false negative, which is the least one here. So we can say that the decision tree has the uh, least false negative. So it might be the best choice here. Next, I have also plotted a ROC curve here. ROC curve shows the trade-off between true positive rate and the false positive rate for different threshold AUC, and the AUC summarizes the model rating abilities. higher AOC means a better separation. Here we can see that the decision tree has the highest AUC value, meaning it ranks journals best. Uh, According to this also, it is we can say that the decision tree is working the best for this comparison. Then I have also plotted a bar chart for comparing the classification models. This group bar chart allows a side-by-side comparison. We can see that decision trees have the highest accuracy, precision, and the recall, and the F1 score as well. The logistic regression has the least recall, means it is missing the actual journals. Uh, Next, I have performed clustering, customer segmentation using clustering. Here, I have selected age, balance, and estimate salary for segmentation because they are interpretable and actionable, and we scale them for distance-based clustering as well. Here is the K-means clusters. We can see that we have used four centroids and assigned each customer to the nearest centroid. Uh, Typically, we can see that the first cluster here is the purple one. We can see all of them mostly have the low age, means they are younger people with a low balance and low salary as well. We can, low balance and low salary as well. It is not changing. Okay. Next cluster, we can see that the uh, orange and the blue one are bit mixed together, but they differ by their salary, the income of the estimated salary. We can see that these are middle-aged people with higher balance, high value customer, and the fourth we can see here is the older one, older customer with medium balance, and these are the retention targets mainly. Next, I have used hierarchical clustering here. This groups the record stepwise, plots the user into four clusters for consistency with k-mean. Uh, the hover data here is very handy. We can inspect the credit score, tenure, number of products, and exited of not their estimate salary. Also, we can see here. This the cluster here maps roughly the k-means segments, but hierarchical clustering can reveal nested subgroups and is useful with the uh, it is useful when we want hierarchical person, like for example, premium customer or non-premium customers, like that. So we have actually divided the whole graph into four parts. The cluster we have divided based on the color here. And we have divided the clusters based on the colors here. So each cluster looks a bit clearer. Here the red cluster have mostly the people have zero balance and inactive customer mostly here. For the blue one, we cluster one, we can see there are younger people with the low to middle balance growth. There are growth opportunities here. For the green cluster 3, we can see there are mid-aged people with higher balance and high values. The purple part here shows mostly the older customer lies in this green with the wide balance spread. You can see the balance spread is very different from 0 to around 200K here. They might require personalized offer for them to not churn. In conclusion, I would like to say that multi-feature linear regression and Lasso's regression capture balance variability well, and the polynomial expression can overfit, validate with the but we can validate the polynomial expression by cross-validation before deployment. For classification, the decision tree performed best in logistic is a rhombus spacetime. KNN underperformed because churn is imbalanced. Prefer recall optimization approach or uh, calibrate threshold for business needs. For clustering, we can say that K-means and hierarchical product are actionable segments. We can all over we can use a decision tree as the production zone model after hyperparameter tuning and class weighting. Mm, I could have
Okay.
also used XGBoost here instead of uh, KN, along with KNN and all. That's it. Thank you.
Okay. Okay, fine, Soumya. So you can just stop your screen sharing. So who next wants to present? Guys, who wants to present next? So there is no one who wants to present. Dipankar Rai, Vinay Raj Singh, Ayushi, Aryan, Afreen, no one? Are you people there in the meeting or not?
Yes, ma'am.
Yes, ma'am.
So are you there? So if you are there, who wants to present next? I guess five of them already presented. Okay, Disha, you can just share your screen and present. After Disha, anyone wants to present? Uh, Aryan,
Hello.
is your project ready? Yeah, Disha, just a minute. You will be going ahead with the presentation. Just allow a minute, okay?
Yes,
Your
ma'am.
screen is visible, okay? Yeah.
Okay, ma'am.
So Aryan, is your project ready? So can you present after Disha? So you won't be able to present Aryan. So anyone else who wants to present?
Ma'am, can I present Shivendra Patil?
Yeah, Shrivendra, you can do it after Disha, fine?
Okay, ma'am. Okay.
Okay, Disha, you can continue, Disha.
Okay, ma'am. Hello, everyone. I'm presenting my mini project on age versus spending score, where I have used clustering algorithms. First, we are going forward with k-means clustering. K means basically the steps include we randomly select K number of centroids, and then each data point is assigned to the nearest centroid using Euclidean distance. Next, we update the centroid according to the data points, and this process repeats until all the data points are covered. First, we have imported all the necessary libraries. Then the dataset is taken from Kaggle. Here we can see the dataset has 200 rows and 5 columns, out of which we are only using 2 columns that are age and spending score. Then this is the initial scatter plot showing the data points where no clusters are formed. Next, we are using elbow method to classify the data points in cluster, where we have used a plot of number of clusters, and within the cluster sum of square, it basically shows how the data points are scattered across the graph. Then the elbow method works like when the points are plotted, wherever the bend occurs, that is the optimal number of the clusters. Here our elbow suggested the optimal number of clusters as 4, hence we have taken K as 4. And then we have used a CLOT score like the second method to calculate optimal number of clusters. It basically measures how well each data point fits in its cluster compared to all the other data points. The score ranges from -1 to +1. And in our case, the highest CLOT score is considered like 0.500, which shows the cluster is equals to 4. Hence, our optimal number of clusters are 4, both according to elbow method as well as the CLOT score. And at last, we have formed a new table. We have added a new column to the table to specify the cluster number to which that particular data point belong. And in this final scatter plot, as we can see, we have four different clusters are formed according to the age and the spending score. As we can see, people between the age 20 and 30 have high spending scores, and the older people have rather low spending score, like budget spending scores. This can be helped for promoting target customers. Then the next method is, yeah, and then I have used hierarchical clustering also. Hierarchical clustering is basically a technique where we build a tree-like structure called as dendrogram to show where the data point belongs. This is the dendrogram formed for 200 data points. It initially starts with 200 data points, that is 200 customers from 200 small clusters. Then based on the Euclidean distance, the closest two clusters are merged, and we repeat it until one big cluster is formed. And then we cut the cluster, like the longer the line is longer, the more different the data points are from each other. Hence we cut the cluster between 150 and 200 score, where we get 4 different clusters. Then we have applied agglomerative clustering here, where again a cluster column is added to specify the data point belonging to the cluster. And at last, we have plotted again the scatter plot, but according to agglomerative clustering. Here we can see the data distribution is a slight different, like the borders are slight different from k-means clustering. And at last, we have compared between k-means clustering and hierarchical clustering, where we can see that k-means clustering gave better CLOT score, hence it is better for this type of data distribution. Thank you.
Okay, Disha. So next is Shivendra. So Shivendra, you can just present your screen and start your presentation.
Yes, ma'am. Yes, ma'am.
Yeah.
Ma'am, my screen visible?
Yeah, your screen is visible.
Actually, ma'am, in last week also I'm not able to share my project to presentation also. So can I complete it now?
Last week's presentation, you're saying?
Is not completed by me. I'm unable to give that presentation.
So you have you just created the video, like the Google in the Zoom? Have you created the presentation video and submitted the project?
No, ma'am. Actually, I only submitted on the GitHub, and after that, I'm not able to join any of the meetings also. But and
But you
uploaded on
have
only
to
GitHub.
submit. Okay, only giving like uploading into GitHub, that is fine. But your performance will be evaluated based on your performance on your project and your presentation, right?
Okay, ma'am.
So uploading into GitHub doesn't give us the access, right? So you
Yes,
have
ma'am.
to
Yes, ma'am.
submit your project. Okay.
Yes,
So
ma'am.
you
Yes,
can
ma'am.
go ahead with this week's project, and for the next week, you can just go ahead. I guess you have done with the first, like the last week's project, right?
Yes, ma'am. Yes, ma'am.
Okay. So then create a video, presentation video, and you can do it like that. So you
Yes,
can
ma'am.
now,
Yes.
as of now, you just go ahead for this week's project
Yes, ma'am. Yes,
presentation.
ma'am.
Fine?
Yes, ma'am. I will complete it in quick.
Yeah.
So, my third week project is on customer segmentation for retail store. So, here actually means uh, I came across the problem like the means the retail store want to means they want to have to grab the main uh, peoples from the market where they can focus on there like that. For this purpose, I completed this project, and starting by I first loaded my project using the means from the drive mount. I loaded my data, and here first means these are the folders where I stored the main file. So from that I loaded the data, and we can see here there are I use the df.head for showing my loaded data is right or wrong. So for this purpose I checked here. Then there is the basic information I checked for like the data shapes and columns, means how much data is there. So here I get around 200 and say 5 columns. I also checked for the missing values, where I missing values. Actually, I came across the check, is there any value missing in my data or not? So I found no missing values here, and then I went for the gender distribution. So actually, miss here from onwards, I completed the EDA analysis for this. So here in gender distribution, the chart shows that how much males are there and females are there. Means if there is a company, then they can focus on to whom they have to means how to set their market, or which means male or female, which where they can focus and sell their products like that. So here we can see that the males are low and females are more in number. Then there is also the age-wise distribution, where we can see that means to understand which age groups are shopping more here, and we can see that the age between 30, the 30 age group is uh, actually shopping more than like others. Then there is the annual income distribution I completed. So here we can check that how much they spend annually. So for this I completed this step. Then I checked for the spending score distribution. So to check means how much they spend like that. So here we can see that most they goes up to means the count goes up to 35. Then I came across the income versus the spending score, where to see the relation between the means relationship between
Shivendra,
yes ma'am.
your screen is stuck or something like that. Can you just scroll down?
I'm scrolling, ma'am. Income
But
versus spend.
I cannot see it.
Wait.
Can you just
Now is it?
reshare?
Yes ma'am, yes
Yeah,
ma'am.
yeah, now,
Now,
now it is.
yes ma'am. So then
Yeah.
I
Just scroll it down from the first and come to this part.
yes ma'am. So first, there is a mounting the drive, means I'll find the which folder where I stored the data. Then I loaded the data here. Then I see the loaded data is right or wrong. Then here is a basic information like the shapes and columns which are present. So here we can see. And then I
Okay.
checked for the missing values.
And then from here onwards, the EDA analysis. So starting with the gender distribution, where I came across that the males are low and females are greater in number. So to check the customer, which customers are there more in number. So we can say that females are more who are shopping more. Then for the age distribution is there. So to understand which age group are shopping in more number. So there is around the age from 30, the 30 age group is shopping more. Then there is a annual income distribution, means we can say to know the economic status of each customer. So here the annual income is like $60, $60,000. Then there is a spending score distribution, where to check how much they spend yearly. So they spend around the 35, and then the income versus spending score. So this is for the relationship and a spot pattern before clustering. So we can understand that males and females are here, and their annual income versus the spending score. So how much they are spending, we can see in this graph. Then there is the means by data analysis, it give us the means the about the data, means help in deciding which features or to use for a clustering. So for that purpose, I use this. Then this is also the age versus spending score. Means based on the age, we can see how many males or females are spending. So I clustered them according to that. Then for further analysis, I completed I imported the required libraries like the pandas, matplotlib, seaborn, and sklearn cluster import by came in. Then I selected the features. So I selected this specific because it shows the means the annual income and spending score, which is required for that. And also means in gender category, the means it is not suitable for the K-means directly, and age could be added there, but the income and spending could be means the clearer business segmentation. So for that, I not added that one. Then next is the elbow method, where means to find the optimal number of clusters. So for that, I use this elbow method. So here this is the means number of clusters shown downwards, and in upward there is the remaining. Then I apply the k-means clustering here. So to segment the means to segment customer into group with a similar income and spending behavior. So for that, and then I visualize their data in this. Here we can see that their data is visually here. And after this, yes, ma'am. So this is the last one only.
Okay. Okay, got it. Fine. You can just stop your screen sharing. Okay. Okay, so guys, we'll just wrap up our session today here. And the who have not submitted their project, please go ahead and submit. I just need to clarify one thing. So, who have already presented their project, this week project I am talking of, this week project who have already presented in the session, they don't have to add a video presentation link in the Google form that has been provided to you. You don't have to go ahead. Who are left with presenting their presentation in the session, they have to, for sure, they have to create a like video presentation of the project. Okay, and accordingly they have to like upload the project in the drive, and based on that give us the access that we can see your project. Like when you in a drive, when you upload a file, then you share the file, you got an option of sharing. When you share the file, you got an option that anyone having the link can able to access the video or able to see the video. Like that one option you get in through. You just go there and give that option the permission, like give the permission like that, and give the drive link in the Google Sheet. Fine. It's like the Google form actually. Okay.
Okay,
Understood,
ma'am.
guys?
Okay, ma'am.
Yeah.
Yes, ma'am.
So
Yes, ma'am.
today and yesterday, who have already done with the presentation in the session, they don't have to redo the stuff. Fine.
Okay, ma'am.
Yeah. So today we'll just stop here and just wanted to ask who are left with, just raise your hand, who are left with submitting the first week and second week's project. Those who have already submitted, that's fine. Who have not submitted the first week and second week project, raise hand. Only two of you, right? So try to submit it by this week. By this week, try to submit both the projects that you haven't submitted. Fine. And Shivendra, you are left with like you are done with the project, like second week's project. You are done, but you are yet to go ahead and present, right?
Yes, ma'am. Yes, ma'am. Only presentation remain.
Okay, fine. So as discussed, create a video presentation, as I told, in using Zoom app or any of the like you can use Loom as well, whatever suits you, you can use that. And based on that, like switch on your camera, microphone, and present your screen. Okay, and then you got the option of recording. So record the video of yours, and accordingly the process I told, follow that. Fine.
Yes, ma'am. Yes, ma'am.
Okay, so try to submit it by this week because this weekend you will be getting the details of the like getting the project of this like this week actually. Fine. So from tomorrow we will be starting with the proper sessions and accordingly we'll do try and do some of the projects based on the topic that we will be having from scratch so that it becomes helpful for you to go ahead and implement any of the project for this week. We have to submit the GitHub link to the given mail ID. Yeah, Priyanshu, you can submit in that form. GitHub link also you can share, or if possible, you like that would be a better version to go ahead. If that is not possible, you can just upload your collab file in the folder and accordingly share the link of the like the Google Drive folder. Fine. So, Payal, which week's project you are talking of? For this week, you are saying? Okay, fine. Then it's fine. So, for this week, you don't have to do anything. And hopefully, the last week and last to last week, like week one and week second project and presentation has already been submitted by you, right, Payal? Okay, great. Okay, great. So, anyone having any other questions?
Yes, ma'am.
Yeah, tell.
Ma'am, week project list contain the unsupervised learning, but I have performed the project on supervised
Right.
learning. Will there be any problem?
No, no, not a problem because this week we have gone ahead with supervised learning methodologies, and next coming up week we will be going ahead with unsupervised. So, since the project, like based on the structure of the project or the curriculum I have been given with, and I have already shared with you, the last week was supposed to be for the supervised, and this week is supposed to be unsupervised. But the project was given like that to showcase because you are in internship. So the project was given in that format so that you already have some predefined idea about supervised, unsupervised, this stuff, and also you need to learn it and based on that implement it. The project has been given, not an issue. You have used supervised, so not an issue, right?
Okay, ma'am. Thank you.
Okay. So we'll continue tomorrow with the sessions. So we'll be going from the scratch from tomorrow and accordingly doing the like completing the theoretical part and eventually work on collab as we usually do in our sessions. Fine, guys?
Okay, ma'am.
Okay, ma'am.
Okay, ma'am.
Okay, great. So, okay, then we'll meet tomorrow. Bye for today.
Thank you, ma'am.
Yeah, thank you. Bye-bye.
Bye bye, ma'am.
Bye, ma'am.
Thank
Bye.
you.
Bye, ma'am. Thank
Bye-bye.
you.
Bye. Thank you. Bye-bye. Yeah, Pranay, you have anything to say?